Okay, good morning, good evening, good afternoon, all of you. Today, in this today's session, we are going to learn about classification. Unit number three, that is supervised learning, which says classification. Now, inside this unit number three, we have already seen in our previous session, that is logistic regression. Logistic regression is a past part of classification, so it comes in unit number three. Now we are going to see uh, KNN, that is K nearest neighbor algorithm. Now to understand this, we are going to simply understand this algorithm and then we are going to read the notes so we can have a better view for this algorithm. KNN. First, are going to see what is KNN. So let's take an example here. Suppose we are given a data set. Now this data set contains name of the student and the score of the student in aptitude and the score of the student in communication. Aptitude and communication. Now based on this two score, we decide if the student is a leader or a intel, or the student is a speaker. Now, if the student has high scoring capacity, if a student score high in communication, then the student is tend to be a speaker. Whereas if the student is high in aptitude, the student is an intel, and if the student have both these capabilities, then the student is leader. Now we are given a data set, a training data set. There are suppose 10 number of such data that are given. Student name are given, and apart from the name, we are provided that students are leader or intel or speaker. So we have to find out a certain relation between this data set. We are given a training data set, and from this training data set we have to make a machine learning model that will test the data set, and will if the test data set is proper and gives the valid output, then we are going to make it in a machine learning model that the final stage will carry on here. Okay, now let us consider this in a graph, in a 2D graph, two-dimensional representation. Now y-axis here says the aptitude, okay, the score of aptitude, and the x-axis will say the score of communication. Okay, so the x-axis here says the score of uh, a communication, and the y-axis says the score of aptitude. Now based on this score, the name of the students or the data points would be somewhere here. Okay, the high the communication and high the if their score is high in communication, they would be standing here. If the score of their aptitude would be high, they would be standing here. Now then there is third one, that is leaders. Leaders would be somewhere here. They have both high capacity, high score in communication as well as aptitude. Now this forms a class. Now method is called classification. We have classified these data points of student into three main class, that is leaders, speakers, and intel. Now this is what the training data shows. For now we have a data point here, and we have to find this where this data point would be in which group. To find which class this data point belongs, we use K and N method. K nearest neighbor method. Now this method uses a formula. Now this KNN method uses a formula that is called Euclidean formula. Okay. So Euclidean formula is used to find the distance between two data points. I will write down the formula here. Euclidean distance, we say. Actually, I will not write this. Euclidean is equal to, we take square root of an expression, that is f1 1 minus f12 whole square plus f21 minus f22 whole square. Now what is f here? F is nothing but the feature that we have taken. The feature that value f11 is the value of feature 1 of data element 1. So this is data element 1, this is data element 2, and the feature 1 of data element is the f11. Now similarly f12 is nothing but the data feature 1 of data element 2. So we subtract this both the elements, and we take a square of this whole expression. Now we do the same with the second element, that is feature of second feature of value of feature 2, for element data element 1, value of feature 2 for data element 2. Now in this way we find the distance between two data points. Okay, so this way we find the distance between two data points, and then if the data we calculate the distance from this number to every other data point, and then we check which data point or which class is nearest to this particular data point. And if this point is nearest according to the distance that we have calculated, then we consider this data point inside the class, inside this class. That is, I think it's a this is the X stands for communication, right? So this would be speakers. It will stand for speakers. Okay. Okay, so we have seen how to calculate the distance between data points by using Euclidean distance. Okay, so with the help of this formula, we will find the distance between the data points, and the nearest data point would be considered as the class of the test data point. Now we will see the notes, what the notes has to say about the k nearest neighbor. K nearest neighbor is one of the simplest machine learning algorithms on supervised learning. Okay, K nearest KNN algorithm assumes the similarity between the new case data point and available cases, and put the new case into category that is most similar to available categories. We have seen it that we check the most similar by taking the distance between the data points, and the closest data point would be considered as the similar to the test data point. KNN algorithm stores all the available data and classify a new data point based on the similarity. This means when new data appear, then it can be easily classified into a well-suited category by using KNN algorithm. Can be used for regression as well as classification, but is mostly a classification problem. Okay, this is one of the points that you can write in the paper. That it can be used for regression as well as classification, but mainly for classification. KNN is non-parametric algorithm, which means it does not make any assumption on underlying data. Non-parametric means it does not make assumption on its own. Okay, this is one of the important points. It is also called a lazy learner algorithm because it does not learn from the training data set immediately. Instead, it stores the data set, and at the time of classification, it performs an action on the data set. Okay, so this algorithm doesn't learn from the training data set. It uses the training data set when a test data set is provided to it, and then it performs an action based on that data set. So this algorithm is called as lazy learner. It does not learn anything from the training phase. Okay, so you can also read this. Now this is an important diagram that you can draw. X2, X1 before KNN, category A, category B. So we take this is a new point and we check which data point is nearest to this data point. So we calculate the Euclidean distance from from category B points and category A points. So whichever is the nearest, that is category A, we make the data point into category A. Okay. Now, how to select the value of k in the KNN algorithm? This is also important concept here that we have to write in the paper. So now we are going to see the how to select the value of k. Uh, Wait a minute. Hmm. How to select the value of k? That is one question. So now K in KNN is the parameter that refers to the number of nearest neighbors to include in the majority voting process. So we take a voting process in this algorithm where we find the nearest distance, and if there are more than two or three distance, that is k, the number of k, we take how many votes are took into consideration is what is the meaning of k. K is nothing but the parameter that refers to how many neighbor we have to considering while taking the majority voting process. Now k can be chosen by doing square root of n, and n is the total number of data points. Okay, so in plot like this, we take we calculate the number of n, and then we take the square root of this n. But there is one condition: if the n is even, we either plus n with 1 or minus n with 1, so that the n can be an odd number, and then we can take the square root of the number. Now, as a very low value of k, so when the k is when we take k very low, that is if we here for this we take only k as 2 and both of them are this one, so it will be a bias and the error will occur because the k would be assigned to category B, which is wrong. So if we take one or two can be noisy and lead to the effects of outliers in the model. Large values of k are good, but it may find some difficulties. Should always go with the large number of k, but we can find little difficulty in finding them. That's another issue. But if we take one or two, we will definitely find an error. Now we will see the KNN algorithm. KNN algo- sorry, KNN algorithm. Uh, Step one. See. We will. I will just read this out, and you will definitely going to understand. So the first step of KNN is that we find the k. Select the k number of the neighbors. We select how many neighbors are to be taken into consideration, and then we calculate the Euclidean distance of k number of neighbors. Okay, we have selected a k, and whatever the k is, we only take that k. We only calculate the Euclidean distance of the k number of neighbors. Now the third step is take the k nearest neighbor as per the calculated Euclidean distance. Now, according to as I have told you before, we find the distance, Euclidean distance, and according to that Euclidean distance, make we take the k nearest neighbor as per the Euclidean distance calculated. Okay. Now the next step is among the k neighbor we can. So now this is one important point here. We have find the k nearest neighbor. Okay, now we calculate the number of data points that are in this neighbor, that are in this class. Now we will, if there are two such data point that is nearest, we will take the maximum number of neighbors or data points that are in a neighbor. See, among these k neighbors, count the number of the data points in each category. Assign the new data point to the category for which the number of the neighbor is maximum. Assign the new data point to the category for which the number of the neighbor is maximum. Okay, now this point I will explain you again. This is an important point. So the step number 4 or 5 is, these are data points, and this is a data point, and this is a data point. We calculate this. Now whatever the maximum neighbor here is, we belong this data point to this. If here is 3, the neighbor, the majority is 3, and whereas here is only 2, we will always go with the 3 data point that is considered as the neighbor of the new data point. So this is our step number 5. 4 and 5. Among this k neighbor, count the number of data points in each category. Assign the new data point to the category for which the number of the neighbor is maximum. And then our model is ready. So we will see the next thing, that is we are going to explain an example here. The example that I have shown you, I think about this example is also same as I have given you previously. The students and their intelligence based on their score. The scores are communication and aptitude. Based on this, we classify it into three groups. That is, category one is leaders, category two is intel, and category three is communicators. Sorry, speakers. So we will give an example here. Now you can read the advantages of KNN. Easy to implement, robust to now noisy training data, effective in large data set. Always need to determine the K. This is a little disadvantage here. We have to always classify or determine the value of K, and hence it will require an additional computational cost. ठीक है? We will require a computational cost for calculating the Euclidean distance. Euclidean distance is a big. It will require. It has a good formula, a large formula that our human mind can take 10 to 15 minutes to find the answer. So, hence the computational cost would be high here as well. And these are the two advantages of KNN. Now, the next topic is that we are going to study is the third topic, that is uh, we are studying naive Bayes classifier, naive Bayes decision tree. This is the topic according to the syllabus, but we are going to see what is naive, what is the meaning of naive, and then we are going to see Bayes theorem, and then we are going to see what is decision tree, and in that way we are going to understand what is naive Bayes decision tree. Okay, so we were at naive Bayes classifier. Actually, inside the syllabus, it is given as naive Bayes decision tree, but we are going to understand what is naive Bayes classifier. So let's see an example here. Naive Bayes classifier is a classification method, and it comes in supervised method. So we are given a label data. Now suppose we have an email box. Okay. Now this email contains two categories, two classes. That is, the first one is the normal message, and the second one is the spam messages. So inside this email, about email of normal messages and spam messages, we initialize some keywords in the mailbox. So inside the mailbox, we have friends, and then come lunch, money, and comes dear. So these are four keywords that generally present in a normal email box, email message. And same goes for the spam. Inside the spam, there are the same keywords that we have taken here. So now we are going to count there are the how many times the appearance of the keywords are there in a particular category. So for normal, there are 14 normal messages. Okay, and whereas there are 8 spam messages. Now inside this 14 dear messages, dear comes at least 8 times, whereas friends come 10 times, and lunch comes 4 times, and money comes at least two times. But in the spam, the keyword dear comes for at least uh, three times, whereas friend comes for two times, and the lunch keyword comes zero, and the keyword money comes 10 times. Okay, so we will make this 10. Now we have to find the probability of this expression. Now given the number count, we are given how many times the keywords can occur in a particular message. We are going to find the probability. Firstly, we will find the probability of a particular message. So the probability of email to be a normal is 14 divided by 14 plus 8. Sorry, 10. 14 plus 10 is, what is 14 plus 10? Like not 10, 24 actually. 0.58. 0.58. And what is probability of spam messages? 10 divided by 24, it is 0.24. Okay, so these are the probability of a message being normal or a spam. Now we get a message in the inbox that is dear friend. Now we have to find this probability of this particular key message, that this message is high, in which probability high, the probability is high either in normal or a spam message. We have to find this question, so we will use Bayes theorem to find it, and I will show you how Bayes theorem is going to work. Now to calculate the probability of the key of the sentence dear friend, we have to go back and find the probability of each keyword. Now probability of dear would be dear upon, and here is 14, so 8 divided by 14. 8 divided by 14 is 0.57. So the answer here is 0. Sorry, 57, right? And the same goes for the keyword friend, that is F and N, and it would be 0.14. And same goes for lunch, which would be, I think, 0.2, yes, 0.28, 0.28. And the probability of money would be 0.0 something, 0.14. Okay, 0.14. And hence we have taken the probability of every keyword. Now this taking of probability of every keyword is also known as livelihood. Livelihood of an element, we say this as livelihood. Now we take for this all the keywords we will take for this dear friends and lunch for the spam element, spam email. Okay, so we have taken the probability livelihood of the spam email. Dear friend, lunch and money, these are the probability of the following livelihood, and this is the probability of the normal email. Now we will calculate the probability of the sentence that is dear friend. So to calculate this, we take the probability of n, multiply by probability of the word dear, and we multiply it by the probability of the word friend. Now we will get an answer something 0.58. multiply by 0.57 and 0.14. 0.57 and 0.14. So let me check what is the answer here. 0.58 multiplied by 0.57 multiplied by 0.1 0.046 0.046. This is the probability of the sentence dear friend. Now we will find for normal email. Now we will find the probability for spam email. So we will multiply it by 0.24 and then we will multiply it by 0.3 and 0.2. Okay, so we will see 0.24 multiplied by 0.3 multiplied by 0. So the answer here is 0.014 equals to 0.014. 0.014, right? So hence the probability of normal this one is greater than this one. So we will go that we will say that dear friend is more probably in a normal email than in a spam email. So this would be our answer for the given problem. So we will go through the notes for once. Bias, naive bias, naive bias. See, this is how they are calculating, right? Naive bias multiplying probability multiplying by probability. And hence we are getting. So you can use this example here and learn the formula for naive bias theorem. Naive Bayes theorem is a supervised learning which is based on naive Bayes theorem. Bayes theorem and solve test classification, high dimensional training dataset. It is probabilistic classifier, which means it predicts on the basis of the probability of an object. Okay, so it is there is input is given to the object and it says that it is email or spam, and then according to that the our probability is being classified, and then the model is being trained. So when the test data arrives in the model, the algorithm can find the proper in output to the given classification. Naive it is called naive. It assumes that the occurrence of a certain feature is independent of the occurrence of other. Okay, this is one of the point. Now we will see what is the naive Bayes theorem. Posterior probability. This is posterior probability, and this is prior. This is prior probability, and this is likelihood that we have calculated by taking B and A. This, as I told you, this is a livelihood. We have taken livelihood. Sorry, livelihood, and this is posterior, and this is prior probability, and this is marginal probability. Okay, then you can say write the example that I have just shown you, and then we move on to decision tree. See, we have seen this before also. The probability of yes, sunny, and no sunny. Don't read this. Just write the example that I have told you. It's much better and much easier to understand. If you go with this, you will be confused. Now we will learn what is decision tree. We will not read entire this because there is very less probability of decision tree coming in exam. We'll just I will just explain you in short. Decision. So now we have a root node. Okay, this is the first node and it is called root node. Root node. Now inside this root node we have to make certain decision. For example, if uh, if today is Sunday, okay, if today is Sunday, then to the left side it will say no, and to the right side it will say yes. And then we will say if yes, then we will say uh, good today is a good weather. Good weather. Okay, good weather. If good weather, then we will move to yes, sorry, no, and yes. If today is not Sunday, then we will say is today holiday, and then it will say yes and no. No, yes. And if today is not holiday, then go to work. And if today is holiday, then plan something. Stay at home. Okay, stay at home. And if today doesn't have a good weather, then stay at home. And if today has a good weather, then go outside home. Go outside home. This is what the decision tree looks like. Now, this is the branch node that comes between root and the child node. This is called as branch node, and whereas this is called as leaf node. Okay, now leaf node is the children node to this parent node, and this branch node is the children node to this root node. Now, these are few important concepts that I have told you in short, and you don't need to read about this entire thing decision tree because it would be just complicated and your brain would be fuzzed up reading all of this. So we will move on to SVM. Now inside decision tree we have a concept called as random forest tree. We are going to learn about it more in the unit 5, that is tagging and boosting concept. But for now we are going to move to support vector machine. So we have seen this and we have seen I think decision tree also. Decision tree. Now we are going to see SVM. Now, what is SVM? Okay, so now the topic is support vector machine, and we are going to understand it in a very easy way by considering an example. So we have a number line, and inside this number line, we have certain points, data points. That is, if a person has diabetes or the rate of diabetes the person has. Okay, if the weight is. Okay, now these are certain data points, and this data point says that the person has diabetes, whereas this says that the person doesn't have diabetes. So, according to these data points, we can have a best centered line that would be this. Okay, now this line is what we call as hyperplane. In this, just because of this hyperplane, we can easily distinguish between the category of the data points. Now, if there comes a data point who is here in the number line, we can easily say that this data point belongs to this group of data points. If it comes here, we can easily say that this data point belongs to this. Just because of hyperplane that we have drawn using the support vector, we can easily classify the data points. Now, if the data set is in two-dimensional representation, and these are some data points. Any data points you can consider, and this is some data points. Now these are categorized into two data points. These are training data. Okay, now we know that this is class A and this is class B. So we can draw a support vector line. This is this hyperplane, and if a data point comes to the right side of this hyperplane, we will say it belongs to the class B. Whereas if the data point comes to left side of the class hyperplane, we say that the data point belongs to class A. And we can draw a line here as well, and a line touching the data point, and we call this as the margin. The distance between this support vector and the hyperplane is called margin. So this was an ideal concept behind support vector machine SVM. Now we are going to read the notes. What does the notes have to say about it? The goal of SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data in correct category in the future. This best decision boundary is called hyperplane. We have seen this in the example. SVM chooses the extreme points vectors that help in creating the hyperplane. So these 2 points that we this one extreme point and this extreme point is the support vector. It is the vector, and we take this vectors this vectors to make support vectors that help in creating the hyperplane. These extreme cases are called support vectors, and hence algorithm is termed as support vector machine. Consider the and you can also draw this diagram in which you can show two different categories, and you can name the objects in the figure, and then you can tell an example here. So what? And then there are types of SVM. The first one is linear SVM, and the second one is non-linear. Linear SVM is used for linearly separable data, which means if the dataset can be classified into two classes by using straight line. Okay, linear is a straight line, and if the data can be separated by a straight line, it is called as linear SVM. Non-linear SVM is a non-linearable separated data, which means if the dataset cannot be classified by using a straight line, then such data is termed as non-linear data, and classifier is used as non-linear SVM classifier. Okay, so very easy concept. There are two types of SVM: linear and sorry, linear and non-linear. And then you can tell about hyperplane and support vector. What are these two components that we use in SVM? And then you can show the example, and you don't need to write everything about it. So we have seen SVM, and now and not very important, but we have content based classification. I think content content based classification. Actually, we have first for recommendation system. Okay, so we were studying about recommendation system. A recommendation system is a type of information filtering tool which recommended the relevant product or service to the user. This you can write the point. You can draw this diagram. I think recommendation engine. It uses actually recommendation engine. It tells user action, and user action then analyzes, and then it goes to recommendations, and recommendations send the data to recommendation engine, and then the engine sends the data to the website and also receives the data from the website, which then goes to the user action. So you can give the example here as Netflix, YouTube, Amazon, etc. And then inside recommendation system, we have different topic or component, that is content based and collaborative techniques. So content based is simply, uh, if you search something, and if you search on Google watches, then you will get the advertisement of watches. So this, you the observation of your own actions is called as content-based filtering recommendation engine. As the name suggests, a content-based recommendation engine recommends the relevant content to the user on the basis of their preferred features of other content. In the collaborative, it's opposite. A recommendation system recommended a user the products on the basis of preference of other uh, users with similar taste. So if you are using Spotify to listen music, and inside your music you have a taste in uh, hip hop or something genre of music, then you will likely that the music liked by others with the similar taste will be suggested to you. So this is called as collaborative filtering. We can differentiate between these two to understand it better, and you can read it out. I am not going to waste the time on this topic. So we have seen this recommendation system, I think. Okay, so we have seen a logistic regression in this unit, and we have seen k nearest neighbor, in which we use a certain formula to find the distance, and according to that distance we classify the new data point to the category of whichever category is the nearest to the data point. And then we have seen naive Bayes classifier, uh, and decision tree, and support vector machine, and recommendation system. In the next session, we are going to study unit 4, that is clustering. We are going to learn about it in an entire session completely, and we are going to finish unit number 4.